Multi-protocol label switching. See, as the word says, this is a protocol that supports many layer 2 encapsulation protocol as well as all layer 3 routing protocols. Not only just routing protocol, even the IP or IPv6, it supports all. That is why the word multi protocol comes. So regardless of your layer 2 protocol, layer 3 protocol, this label switching is possible. So you don't need to worry like, oh, I have point to point. We are going to use this protocol without any extra care. Like I have a frame relay, I have a point to point, I have HDLC, I have Ethernet. No need to worry about all those things. MPLS can work. Yeah. So multi-protocol. Now, what is that you're going to do? Not routing, rather switching, based on not MAC address, or sorry, not based on IP address, based on the label. See, we still have layer 2. We still have layer 2 MAC addresses in moving the packet from one to another, one router to another router. We still have that layer 2 re-encapsulation of packets every hop. We don't have any change in layer 2, but there's a big difference in routing and MPLS. In routing, we do a layer 3 header lookup, means every routers. Every routers will do a layer 3 header lookup, and then it will use a CEF table, which is already there on every routers. Using that, the packets will be forwarded. The forwarding decisions are made. Let me repeat. If there is no MPLS, what really the router does is, a packet arrives, a router looks into the layer 3 header of the packet. In that layer 3, if you see down here, there will be destination and source IP address. And there will be many other fields here in layer 3. Like flag, version, total length, TTL, protocol, option, DSCP means type of service field, lot of fields, among which one is destination. So the router needs to scan every field to know one small information called destination. After which it compares the destination with a CEF table which is already there on the router. And if the CEF table says go via G0/1 out, CEF table says go via G0/1 to this 10.1.1.2 address, which is the router here. And then the packet will be now getting ready with the MAC address of this exit interface and the MAC address of this next router. And then the re-encapsulation happens, the packet gets moved from here to here. So normal routing without MPLS is what called as normal routing. This is what happens. When a packet comes inside the router thoroughly reads every single bit of the layer 3 header, and sometimes the layer 3 header will be like 1000 plus bytes size, 1000 plus bytes size. But what is the size of the IP address that you are looking for? Just 32-bit 4 bytes. In order to read that 4-byte information, you need to read that 1000 plus bytes of information. Only after that, you will know the destination where to forward the packet. The router will know. For that destination, it will look into the CEF table. CEF table is a routing table in a layer 2 level. CEF table on the router. CEF table is on the router. IP header is on the packet. Now, the CEF table on the router is the table, a buffer, where the route information for the destinations are saved in a layer 2 level. So when a packet arrives, it need not to go through a layer 3 engine, layer 3 routing table rib process, not necessary. You can simply look into the layer 2 routing table, which is called CEF, and quickly forward the packet. So, in short, what I want to say is even before MPLS, you have CEF, which avoids looking into the layer 3 routing table. Now with MPLS, we add something more. What? We avoid looking into layer 3 header of the incoming packets. Yes. You no need to read this big 1000 bytes of information to know just 4 bytes of IP address. You no need to do this after MPLS. If no MPLS, you need to do this. With MPLS, you avoid reading this big header to know the destination. To know the destination, you will read only one teeny tiny layer, MPLS, which is total size is only 32 bits. The total header size of MPLS is just 32 bits. Whereas the IP header is more than 1000 bytes sometime more. Sometimes it is 64 bytes, sometimes it is, anyway, 64 byte is also too big. 64 bytes will not have any payload. So when you see payload packet, when you communicate, some payload is going, right? I'm talking to you right now. Every packet carries some data, the payload. Definitely the packet size is going to be bigger. Let me quickly show you that in the Wireshark. So here, this is a UDP packet. If you see here, the IP header is here. And if you see the size of this IP header, it is, the total length is 160 bytes. Just the small header length itself, it's 20 bytes. Total length of this packet is 160 bytes. And if you see here, just to know this destination IP address 140.250.84.4, you need to read all these bits, version bit, header bit, DSCP bit, total length, IP identification, flag. If you open the flag bit, reserve bit, don't fragment, more fragment offset bit, time to leave, protocol bit, header, checksum, source address. After reading all this only, you can come to a conclusion to whom the packet belongs to which network the packet needs to be forwarded. But when I have MPLS, only 32-bit header is more than sufficient for the router to conclude the destination. So if MPLS need to be processed instead of IP header, if MPLS need to be processed, if MPLS need to be utilized, in the OSI reference model, this MPLS should stay immediately after layer 2. This is layer 2 data link layer. And here comes the 32-bit header called MPLS. After which you will have a normal layer 3 IP header, which I showed you. So when I enable MPLS on a router, that router starts adding this new layer to this OSI. It adds the layer called MPLS right immediately after layer 2 and before layer 3, so that when a packet arrives after reading layer 2, the router will be getting chance to read the MPLS, and that will be enough for router to decide where the packet need to be sent. So it will not read layer 3 header. See how much you can save the processor utilization and the time taken to process. Only 32-bit you are going to process, and you will know the destination. You see, in some airports, small airports, the boarding pass issuing place and the gate is same. The gate and then the boarding pass issuing counter is same, because it's a tiny airport. Very less people come. One or two aeroplanes come every day, so they don't have two different counters. You go with your documents, they verify all the document, and that's all. You are ready for boarding. It's the same person who is going to allow you inside the flight. But he has to refer a lot of things now to give you access to the door. You need to check your passport, visa, the place where you stay. Though the immigration process also happens simultaneously. Yeah, of course, it is like that. Some military airports are like that. Everything in one place. And then it takes time for finishing check-in for each passenger, more than a normal airport. The reason is a lot of things need to be verified before allowing you to go inside the gate, the the plane door. To avoid this, what is done is already a label is given in the normal airports. In normal airports, the domestic or international, a label they give you after verifying all your document. They give you a label. What is that? Boarding pass. So that In the gate, there's no need to waste time checking all your documents. You just show the boarding pass and you're good to go now inside the plane. Which means the boarding pass, what it means that everything is already checked. We have issued a pass to get in. So again, they no need to ask you passport. Though some international airport does this unnecessarily after every immigration, every boarding pass, everything. Still, when they board you, they ask you to keep your passport and the ticket ready to show. That's unnecessary. They are doing a necessary job. So what I'm coming to say here is, if there is no boarding pass counters, the time taken for each passenger to get into the plane in the gate is big, more. Because someone has already verified all the document and given a label. Just by looking into that label called boarding pass, you are allowed to get inside the flight. So boarding a flight is less time. The flight need not to wait in the ground for a long time now. Just comes and boom, takes up. Because everyone is checked in very fast just with a boarding pass. Likewise. The very first router only will read the layer 3 header. Very first router in the MPLS. It's like a ticketing counter. It's like a boarding pass counter. It does all thorough verification of layer 3 and punches a label. It pushes a label. Let's say you got the first router, second router, third router, fourth router. Now this is MPLS domain. And here an IP packet comes. Only this router will read the layer 3 header. And this is an MPLS domain. So before sending to R2, R1 is going to push a label MPLS header and it will send the packet. So that R2 need not to read layer 3 header. It will simply read this MPLS header and again it will push another MPLS header and removing this old MPLS header, it will put new MPLS header and send the packet to the next guy. And this guy, just looking into the MPLS header, he knows the destination, puts another MPLS header and pushes here. So this is the place where the MPLS header is initially introduced to the packet. We call this a router as increase router, where the push operation happens. Label import. Push operation, adding of MPLS label happens here. And here it is going to be a swap operation. Swapping of label. After receiving the packet with the label, R2 knows the destination. Now it knows what label to put so that R3 will understand my packet. So it puts the label which is understood by R3 and sends it to R3. We call it a swap label. Before sending it out to the IP world, the label is popped. So this is what the three different label operations: push operation, swapping the label, popping the label. So when it goes out of this MPLS domain, it goes out as a normal IP packet. MPLS labels are pushed on the increase router and labels are popped on the egress router. In the middle routers, only swapping of label happens. Label swap happens. Okay, what is next? I told you the MPLS header is only 32-bit. And what is the destination IP address size? Which is also 32-bit. But are we going to use the IP addresses to know the destination? No, instead we are going to have a label. So this router is adding an additional layer called MPLS, so that from now on the following routers will not see the layer 3 header, just the 32-bit MPLS header, which has got a label to tell where the destination. Sorry, which one is the destination? Where the destination, it will see the CEF table only. But what is the destination will be known from the label, not from the IP address. Which destination is known from the label, where the destination is known from the CEF table. So CEF is still there. Now on the LSR routers, what is LSR routers? Label switch routers, meaning every router that supports MPLS is an LSR router. Don't think it's a special router. A normal routers that you already have, you enable MPLS, we call now as LSR. LSR routers. It's not ASR router. ASR is a specific series of router. This is LSR router, label switch router. LSR. So every router that uses labels to decide the path is an LSR router. Now on the LSR router in the CEF table there will be new entry called label. Yeah. So when you enable MPLS, even the CEF table gets labels in it. Without MPLS, CEF table will not have any labels. Yes, yes, Santa, please, I'm listening. No, it's the same thing. I'm not talking about anything. I'm just talking in general. I'm talking about a router. A router has got a CEF table which we learned earlier. Now after enabling MPLS, okay, see, I don't know what to pin here because a router, I'm talking about a router that is running MPLS. The router that is enabled with MPLS will now called as LSR. Will be now called as LSR, label switch router, that I have written. Now, what is the additional thing that you will have in label switch router is in the CEF table also you will see labels. In the CEF table of the router, you will see labels. So those things I'm going to quickly show you by taking I'll take 4 routers and quickly design a topology, enable MPLS, and I'll show you the CEF table before MPLS and after MPLS. Let's do. So far what I have spoken, I've said MPLS is a label switching, not routing. And again, MPLS is not a routing protocol. MPLS is a protocol that quickens this routing decision by adding a label. So instead of reading that big layer 3 header of every incoming packet, you just read the 32-bit layer and you will know the destination. This reduces the time taken, process utilization, and so on. That's the main story. CEF is on the router. The MPLS that you enable makes changes not only on the CEF table, it is also doing changes to the packets by adding additional layer called MPLS layer. I'll be showing you that shortly in a Wireshark. We are going to test the reachability between R1's loopback and R4's loopback. I want the labels to be used as the packet moves from left to right or right to left. Now, yes. First, basic normal routing I'm going to show you. For MPLS, it is recommended to use a link state routing protocol. So don't use EIGRP or RIP, but if you're using it's okay, but recommended is link state routing protocol. If you're using EIGRP, still you can have MPLS. But, sorry, let me repeat the sentence. Because you are running EIGRP, you should not think that I cannot use MPLS. You do have a option, definitely, because it's a multi-protocol. But recommended is a link state routing protocol. That I want to emphasize. Don't say that EIGRP, you cannot have MPLS. Don't expect someone to switch to OSPF because of MPLS. Not going to happen. So you can still have MPLS, but the best output, the performance, you will see only if you have link state routing protocol, especially when it comes to traffic engineering with MPLS, which will be a later subject for us. I would like to run OSPF. Let me also finish router 4 before I move on to the other intermediate routers. Router 4 will have 34.4. And loopback will have 4444. This is router 4. Now, router 3. Router 3G4/0 will have 34.3. 3/0 will have 23.3. Sorry. And the loopbacks are optional here. We are not going to anyway. No problem. Let's put a loopback also here. 33333. Copy router 3. Just one more router, then we'll be into testing. Router 2. G4/0 will have 23.2. G3/0 will have 12.2. The loopback is 222. Wonderful. Router 2 is also ready. So now it is simple routing I have done, nothing new, no MPLS. First of all, I want to show you the CEF table. On router 1, when I type show IP CEF, it is enabled by default, you see. It says to reach 4444, this is the gateway, means this is the IP address of the next router, and this is the exit interface to go out. Usually, we see these things in where? In the routing table. But I told you CEF table is the routing table in the layer 2 level. Let me show you in the routing table. See, this is the entry in routing table. This is the entry in CEF table. Routing table says to go to this destination, you need to go out on this interface. It's same information here. You need to go to this next stop because from there only you learned it. So this is the next stop. So instead of reading all these things in a routing table, now we use CEF table. It is very short and sweet, and it is in a layer 2 level. That's the biggest advantage. See, we have different algorithms, layer 2 algorithm, layer 3 algorithm. Layer 2 algorithm itself can give you this info. You no need to go to layer 3 algorithm and waste time. Again, this is not after MPLS. This is even before MPLS. You have this facility. The CEF making your routing faster. Even before MPLS, your routing is faster. So when I say trace route to 4444 with a source of 1111, I can see the packets getting routed via 2, 3, and 4. And in the CEF table, do you see any labels? No. But after I enable MPLS, you will also see a label. Not only in this CEF table, even in the packet. Right now, if you see the packet, there won't be any MPLS label because we have not enabled MPLS. All right, let me try pinging from R1. Ping 44444 with 11111. Now, if you go back to the trace, you see ICMP packets from 44444 11111. Do you see after Ethernet? You see what after layer 2? What do you see? Layer 3. Please pay attention. After Ethernet, what is the Ethernet type? It is IPv4. How do you know? See, it is written. Also, it is written 0800, which means IP header. For MPLS, it will be different. It won't be 0800. Now I'm going to enable MPLS and then I'll come and show you that in between this Ethernet and the Internet protocol, there will be a new layer called MPLS. Let me try to enable MPLS quick. Enabling MPLS won't take much time because the command is same on both global configuration mode as well as on the interface mode. Listen, you cannot enable MPLS on the interface, which is logical. Listen, interface loopback 0, I try to enable MPLS IP, see what happens. It is not allowing, it says MPLS is not supported on the interface loopback. Yes, it is not supported. Next. First of all, to make this router LSR, you type this command MPLS IP. But most of the people won't type this command. Why, you know? When you enable MPLS on the interface, this gets enabled. But it's a good practice. I like to always tell the router that I want the MPLS service. So this is not going to run MPLS on any interface, but the router is now getting ready to support MPLS feature. This is like enabling MPLS feature. But if you enable on the interface, this feature gets enabled automatically. So some people will not type this command in the global mode. Nothing wrong. No, nothing wrong. That's what I say. If you enable, see, on the interface G3/0, if you say MPLS IP same command, it enables MPLS on this interface as well as globally. Okay, so people don't follow that, but I like to. Only on that interface, and the feature is supported now on the router. This is not going to enable MPLS on all interface. No. This command that I have selected is not going to enable MPLS on any of the interface. It is not going to enable on any of the interface. It is simply saying, okay, I'm ready for MPLS. And then I go and say, okay, if you're ready, only run on this interface. Okay, this is the best, this is the actual procedure, but you know, most people will do like they go straight to the interface and say, I want this interface to be MPLS. Immediately, the global process will also start. Now, MPLS is running on this interface. What is the proof? Show MPLS interfaces. It says MPLS is right now running on G3/0. That's perfect. Let's go to the next router. I'm on router 2. MPLS IP interface range G3/0, G4/0. MPLS IP. This range command may not be supported on every router. So now you see there is a LDP, neighbor label distribution protocol, is what MPLS uses. It has discovered a neighbor. You see the router ID of router 1 is this. It uses the loopback address as the router ID. And this router ID need to be a reachable address. More about this we will discuss in next class. Now, what I'm showing here is the neighbor is automatically established with router 1. Show MPLS interfaces. You see these are the two interfaces where we enabled MPLS. As I enable MPLS, LDP gets enabled. It is LDP the one which discovered the neighbor for you. Now you don't need to enable LDP. That is what I indirectly say here. When you enable MPLS, LDP gets enabled. Now next is on router 3, I'm going to enable MPLS, same like as I did in router 2. MPLS IP interface range G3/0, G4/0 MPLS IP. Now you will see neighbor with R2, so it has come. And I'll also enable on R4. See, for a change, what I'm going to do, I'm not going to enable globally. I'll do only on interface. This is just to tell you that globally it gets enabled automatic. MPLS IV, that's all. See, now you will see a neighbor. See, you got a neighbor. So though I forgot to enable it globally, it gets enabled as I enable on an interface. The process gets started uh, as soon as I put this command on the interface. Now MPLS is enabled everywhere. Pay attention. 1 minute. Now this is the important time. I'm going to R1. I'm going to ping again the same. See again the ICMP packets going from 111. Look at this. After Ethernet comes what? MPLS. It is only 32-bit in size in total. Okay, this is only 32-bit. After Ethernet comes MPLS. After MPLS only comes IP. And you see a label number called 18. And in the Ethernet header, if you see, the type is not IPv4. The type is MPLS 8847. For IPv4, it was 0800. This is MPLS 8847. See, if someone is trying to give a tough interview in MPLS, this is what they will ask. What is the MPLS type in Ethernet? Or what is the Ether type for MPLS? 0x8847. Right now, more into this one will come later. Now, I would like to show you something here. Earlier, when I was tracing the route, there was no labels. But if I trace it now, I'll see some labels involved while tracing the route. And I can show you the CEF table now. Show IP CEF for 4.4.4.4/32. Now you also see a label in the CEF table. Earlier you were not seeing label. Right? So I have given you a very good introduction to what MPLS is. It's just an introduction again, a good fundamental of introduction to MPLS. Why MPLS? What MPLS? And how MPLS is what we have seen. But still there is much more detail on what MPLS is coming in next class. And then we will see how MPLS routing logic or label switching logic works. How can this label switching, you already know a little bit of how label switching is making the uh, switching decision faster or routing decision faster. More of this will be explained in our coming class. Now, based on whatever I have delivered to you today, do you have any question? Only on the portion that I have covered on MPLS today, do you have any question?
I have a question about talk about the MPLS with layer 2 technology, right?
I did not say that. This is coming after layer 2, so that you no need to look into layer 3 header for routing. You will be just looking into layer 2.5, you can say. MPLS can be called as layer 2.5 because it's not layer 2. And it is not layer 3 also. It is in the middle. So you should not call it as layer 2 concept.
Okay, but it's not layer 2, it's not layer 3. What is that?
It's 2.5. It's 2.5 layer. In OSI reference model, there is no layer called MPLS layer. Now it's an additional encapsulation done to the OSI. So you cannot call it as 2 or 3 because it is not as per the default OSI standard. This is later encapsulated, additionally added layer.
Why this question? Because we have some, because MPLS is layer 2 protocol.
No, that's wrong. That is wrong. It is not layer 2 protocol.
It's not layer 2, layer 3 is
It's 2.5.
2.5. We cannot call it also
It is not a routing protocol. It is a protocol that does the additional if it is not a protocol, how can it do encapsulation of with the label? It is a protocol. It is a protocol that is for assigning label, not only just assigning label. It is a protocol that uses the label to process the forwarding decision.
You know, I have a lot of problems to understand this.
Hmm.
Today, now I'm going to understand it with you.
Hmm.
Because it's very,
Easy.
I don't know if it is easy, but
Was it easy today? Did you understand all that I speak?
yeah,
I tell you, what I have delivered today is the actual MPLS story. Why MPLS? Why MPLS? I have already answered. Why I need MPLS? So that I need not to look into that big layer 3 header to take a decision where to send the packet. Hmm? So more about how and all those things is coming. Right. So do you have any question?
no, Jay. I'll do this lab and then.
All right. So thank